Okay, so now we really are at the heart of the exercise. We know what it means to cut things up. We know what it means to paste things back together. So now we just have to put all of this information together in order to get what we want. So the typical situation is like this, where in our window manager, we have our windows one way around, which basically means that the screen has been cut up like this, right? But now maybe the user would like to look at this back window instead. So that means that we would like the screen to be cut up like this. So we need a way to recut the screen to be the way we want. And the way we could do this in general is we could just make all of the cuts. So we make this one and this one. And then after we've done that, we paste things together if we have to. So some of these pieces we're already happy with, right? So for example, this piece is perfect. That's the piece we want. But these two pieces here are two pieces, but we really would like them to be one piece. So what we can do is we can say that, well, we can cut the piece we want like this, and then we get two pieces that match what we already have. So that's good. And now if we only could explain how we can turn the pieces we have into the pieces we want, which in this case would mean just pasting these things together, right? Then we will be happy. So that is the notion of a recutter that we'll get to. So the first thing we have is the notion of just a cutter, which is actually taking a cut and a whole thing which we are happy with, if P is the happiness predicate, and it's making sure that all the pieces are also happy. Right? And to see concretely what this means, I would recommend that you do the vec cutter example. And then here we have this notion of a recutter. So the first notion is that of when are the cuts good. So either the thing we have is already all of the pieces. That was the case when we were already happy. Or we can make a further cut and then the thing we want are exactly the pieces of the cut. So that was when we could make one more cut. Right? And here is the complicated but important concept of a recutter. So this says that if we have a cut we want, but we have been given a different cut, then a recutter is something where we can specify the pieces we want. So remember that was the green pieces that we had, and we can specify the pieces we have been given in such a way that they are related by the subcut relation pointwise. So that means that the pieces we want are subcuts of the pieces of the cut we want, and the pieces we've been given are subcuts of the pieces that we've been given. And then we can convert the given subpieces into the pieces we want. That's the good notion, right? And then typically how we convert this is exactly by pasting things together. So let's assume that we have a cutter and that we have a recutter. Then first of all, we can upgrade this cutter for Q into a cutter for many cuts of Q. And secondly, we can then use that to exactly overlay cuts. So if I have a way of turning a single back piece and many cuts of Q front pieces into what I want, then I have a way, then I want to implement a way to turn many cuts of P back pieces and still many cuts of P front pieces into the thing that I want. And that in turn, we then going to be using to make matrices. So the first thing we need is to be able to combine cuts. So just like we could combine pastings before. Right? So this says that if we have a cutter for C and we have a cutter for D, then we can make a cutter for C plus D if we have enough other pieces. So in particular, what we need is a way to jank the G into an all. So if I have a G of an all of P, then I should be able to make an all of a G of P. So that's going to be important for building this, just like it was for the comp paste before, right? And then concretely, we would like to do this for vectors. So we make exactly such a junker for vectors. If I have a vec of an all of P, then I get an all of a vec of P. And using that, you should be able to instantiate compcat to make a matrix cutter. So we are starting to build the pieces we need. And then, so this was all assuming that we actually had, right, so that's making a cutter for matrices, but we also need a recutter for matrices. Right? So we do that by first making a recutter for NatCut, because remember that a matrix is a vector of vectors. So if we can do it for just one vector and then combine it, then that would be good enough for us. So what we're doing here is basically the same thing that we were doing here, but in only one dimension. So it's a little bit easier. Right? Okay, so hopefully you can do that. And then you can make a recutter for NatCut, and then we can combine recutters in multiple dimensions. If we have a recutter for C and we have a recutter for D, then we would like to make a recutter for C plus D. So that's the kind of rectangular thing. Right? And when you've tried to do it, you'll see that there's going to be 4 different cases where the given cut and the wanted cut could either be in the same dimension. So that would be something like this, that you want a cut like this, and you get a cut like this, and then you can recut in that dimension. Or it could be the case that the given cut is in one dimension, but the wanted cut is in the other dimension. So then what you can do is you can do all of the different cuts in all the dimensions and then put things together in each dimension separately. Right? So there's a little bit of hard work to get this done, but after this is quite smooth sailing, I think. So this is the big final thing before we actually can start building applications. So